There are times where you may get serializable even if you do not ask for it. I did not order the serializable isolation level, but I may get it, and this is actually quite easy to show. We will be looking at foreign keys and cascading updates. So I'm gonna go ahead and drop my current foreign keys that I have on two tables. I have foreign keys on ag.firstnamebyyear and ag.firstnamebyyear state. The reason that I'm dropping them is that they are not cascading updates and deletes, and the feature that will escalate your isolation level that I'm going to show you is cascading updates and deletes. So I'm going to recreate those foreign keys, and now the foreign keys say the parent table ref.firstname. If there's an update or a delete in there, you need to cascade it down to the child table. The children are ag.firstnamebyyear state and ag.firstnamebyyear. So those commands completed successfully. I'm also going to create some indexes on my child tables for the foreign keys on the child side. On the parent side, ref.firstname, first name ID is the primary key. The parent's already indexed, but my children, I'm gonna put non-clustered indexes on first name ID on them. So I'm cascading deletes and I'm looking for, hey, who are these children with the first name IDs? I can find them quickly. So this is a good practice to index my foreign keys, and that completed successfully as well. So now what happens, I'm gonna start cascading some deletes. Ref.firstname has two children, so I'm gonna cascade the deletes for first name equals to ag.firstnamebyyear and ag.firstnamebyyear state, but I'm leaving the transaction open, I'm not committing it. If I go into SP who is active now, and I look at those locks, well, what do I see? Well, I see the comment, right? But we can confirm by looking at the TC rule that this is running the delete. If I go look at the locks on my delete, well, that's a lot of locks. Here's the locks for ref.firstname. Here's the locks for the history table, because I still have that temporal table created. And here's the locks for ag.firstnamebyyear. Hey, check out, I have key range locks happening on ag.firstnamebyyear. Similarly, on ag.firstnamebyyear state, which is another child, I also have key range locks in that table, right? I will only see, request mode range if I'm getting key range locks. And this makes sense because although I didn't ask for serializable anywhere. I was not in serializable isolation level when I ran this delete. And it has to do this because this is talked about in a blog post by Connor Cunningham. We need to use, if I'm cascading these deletes from the parent to the child, I can't just protect the rows I'm deleting in the child. What if someone inserted a row with the key that I'm working on? Right? I wouldn't then be deleting it. I could be left with the value that shouldn't be there at the end of my cascading delete. That would not be cool. We need to protect a range of the rows. That means, though, that if I'm using cascading updates and deletes, I'm going to get potentially a lot more blocking and maybe more deadlocks than I thought I would if I actually do cascade the updates and deletes frequently. I mean, if you have these in place and you just never use them, you're not going to notice it. So depending on where you have your foreign keys set up, I have absolutely run into people who said, oh yeah, we had to stop using cascading updates and deletes because the blocking was just crazy. So we had to come up with a different way to handle these situations on our own because there was just too many blocking and deadlocks because of the key range locks. So we can get escalation to serializable even if we never explicitly asked for it, just because it is needed in that situation.